My name is Filipe Ximenes. I'm from Brazil, a city on the northeast of Brazil called Recife. I have about 7 years of experience with web development. And I love working with Django and RESTful APIs. Lately, I've been working a lot with React as well. You have my contact information there. I'll also share the link for the presentation later. All right, so I'm a software developer, and I'm one of the co-founders of Vita Software. We are a team of experts working with our clients to build products. We have a great team of designers and great team of developers, and we build products end-to-end. Most of our clients are from the US, mainly from New York and from San Francisco, so now and then we pop around, we come to conferences, so feel free to reach us. We love to share, and we have a very active blog, so if you want to check it out, the playbook is also very interesting. We share a lot on the way we work, the things we do, how to communicate with clients. So, I mean, for any consultant, it's a cool tool. We do a lot of open source as well. So I brought 2 links here. The first one is a boilerplate. Since we're always starting new projects, we keep that pretty much up to date. We have a lot of linkers and very cool tools. So if you, if you're doing a Django and React project, there is also Tapioca Wrapper, which is a client maker in Python for RESTful APIs. So feel free to check it out. All right, so this talk is going to be about design patterns. But before starting about code, I want to talk a little bit about architecture, like actual architecture, buildings, ROMs, that kind of stuff. And there is this book called A Pattern Language from Christopher Alexander, which is like build the basis for what we know now in software as design patterns. And in this book, he had 3 main goals. So the first one was to create a framework where he could have an elegant format to refer to and debate. He wanted his patterns to form a language that produces coherent objects. And the last thing he wanted was to improve people's life, right? So these are the 3 main goals for the framework he created. So just for example, imagine those 2 are like paths in a park, in a public park. And I want you to think about which of those do you think is a more pleasant path for a park? Right? Good. And to help you answer that, I brought to you the pattern 121 from the book. It's a pattern about paths and goals. And it says, the layout of paths will seem right and comfortable only when it's compatible with the process of walking. And the process of walking is far more subtle than one might imagine. So to be honest, I didn't give you enough information to answer the question I asked. Because we don't know anything about this place we're talking about. We don't know if there are trees there. We don't know if there are mounts. We don't know anything about this. So the way people feel more comfortable walking there, it's kind of hard to know without that information. And this has a lot to do with this thing called desire paths. So in this picture, you can see there are 2 kind of paths running along. And the one on the right, it seems to be hitting a fence. And probably because that fence didn't exist before, while the other one, which looks like a newer stuff, it's running around. So like, you can see from this desire path how people want to approach the house and reach it. Here's another example. And here you can see some trees. So like, the way people walk will conform to what's around them. This one is very interesting because like, this is a desire path where probably initially it was just like marked on the ground from like, you didn't see grass there. But like at some point, people decide to make it a fixed place. So like now this is a proper path. And this is very interesting because it has a lot to do with the way we build our cities. So whenever we see a big street, a main road, or a very old street, it's probably there because of a reason. It's probably there because at some point there was a rough earth road that people used to pass by car. And before that, there probably used to be a trail in the forest. So like, it's just how people used to interact with the place they lived that formed that street. So we talk a lot about patterns and how they're evolving. And here's a quote from Christopher Alexander, the writer of the book. And he says, "This idea comes simply from the observation that most of the wonderful places of the world were not made by architects, but by people." So here we're talking about pattern, how people interact with those ambients, and how that's probably the best way to build good architecture. All right, so we talk about pattern, and the other thing we want to talk about is language. So just like in spoken language, we have words that they have meaning, and we put together words to convey more meaning. So a phrase is a lot more powerful than just like loosen words. And when we talk about a pattern language, in this case for architecture, we also want to join together words, in this case each pattern, to form a language. So I talked about the pattern 120, and here's the pattern 121. It talks about path shape. So streets should be formed for staying in, and not just for moving through the way they are today. And pattern 241, it talks about seat spots. Where outdoor seats are set down without regard for view and climate, they will almost certainly be useless. So as you see, each of those are very meaningful, and they have a sense by their own. But when you put them together, you can build a city. And the book covers from like this city stuff, city size patterns, to small rooms patterns. So you can use those to build ambients. But not only to build ambients, but to build coherent ambients and objects. And this means that like, if you give two persons this book and these patterns, they should be able to create at least, they should be able to reach a similar solution to a given problem. So this is coherence. Cool. So we covered what I want to talk about on the architecture part. Let's move on to software. And the relation between those the design patterns we know in software and the book I talked before was that the software one came after, and was written by the Django 4, and it was inspired by the pattern language book. And when they wrote that, they wanted to transpose the ideas Christopher had for architecture. They wanted to do the same thing for software. And I brought to you two of the patterns. This book has 28 patterns. They were written in Java. The examples are in Java. They applied to any software language, but they were written in, the examples were in Java initially. And it doesn't mean that there are only 28 patterns. Patterns keep evolving, and there are new ones every day. But the initial ones were 28. So I brought two of them for you. The first one is the adapter pattern. So the adapter pattern, it talks about how you integrate code that's not in your code base with your code base. So for example, a open source lib or a closed source lib that you only load the docs. So the example I brought to you was these two classes. Let's suppose we don't have control over them. We are just using the library. So there's the Facebook consumer, and the Twitter consumer. Facebook consumer has a post new message method and a get latest timeline post method. The Twitter consumer has a tweet message and a get latest tweet. And the problem we are trying to tackle is just like we want to get the latest post in each of those social networks and want to save it in a database. So this is a pretty straightforward way to solve it. There are two functions, and each of them calls the expected consumer library, and done. It should work. The problem with this is that it's not very generic. It's not reusable. We are not sharing in code. If we want to, for instance, post to Instagram, we have to just write a new function. And I mean, those are pretty easy and simple examples. You're going to be running through much more complex stuff in the real life. So the patterns I'm bringing here and the examples, you might not understand why they are useful from the example just because they are too small and too simple. But I'm sure you'll be able to use those in other situations. All right. So how are we going to adapt that? So the first approach will be to create these two adapter classes. The first one for the Facebook consumer and the second one for the Twitter consumer. They both receive a consumer object, right? And they both have a method called getPost. And each one will call the corresponding method in the corresponding client. And now we can have a single store post function. And done. I mean, we kind of are reusing more code now. It should be better for our code base, more extensible. The second version I brought for that, it kind of used the same approach, but this time, instead of having two separate adapters, we created a single one, and this adapter receives a consumer and a method name as a string, and use the get attribute function to just call the correct method in each consumer. Again, the store post is pretty much the same. We just made the code more generic. So we just call post adapter with the Facebook consumer and say what's the name of the method to call there, and done. You can call store post with it. Same for Twitter, but we use the get latest tweet method. The last version I want to show you about this is instead of adapting by object, by instance, I'm adapting by inheritance. So instead, and I mean, the approach you're going to use in your software, it depends on what library you are trying to adapt. It depends a lot on whether you know or not, you have access or not to the internal methods of the consumer. But here, we just extended from a class, and we write a get post for both for both new classes, and we call it directly. So we just inherited and created a new common method that calls the correct method inside the other class. And I wanted to talk to you about the Python Social Auth library, which is, for those of you familiar with web development, probably in using Django or Flask, you probably hit that sometime at some point. Python Social Auth, it helps you writing social login for many different providers, such as Facebook, Twitter, and many others. And it also works with Django, with Flask, Pyramid, and many other frameworks. So it's a very extensible library, and was actually one of the reasons I started learning about design patterns. So I just wanted to show you how it uses adapter. So this is the source code for Python Social Auth. It has this backends folder, which with a lot of providers, social login providers. You can see that tons of those. And I'm going to open the base class, which is oauth.py. And there you can see, so oauth.py, you can see there is a oauth extending from base auth, and oauth has extra data method. And there are two other classes. The first one is base auth 2. Those are just protocols for doing authentication. And then the base auth 2, so base auth 1 and base auth 2. OK, so now showing the Twitter. And the Twitter adapter, it also extends from base auth and overrides the user data method. Facebook extends from base auth 2 and overrides user data. So pretty much what I show you on my examples. Cool. So this is a real life case for using an adapter. Now moving on to the pipeline pattern. So the pipeline pattern is useful for when you have like a sequence of steps you want to run, and each step takes the response from the previous step to do something. And in this example, I'm just like, it has no actual code. It's just like few functions with print statements. And what it does is it's supposed to download a page, find YouTube links in it, and fetch those YouTube videos and store somewhere. And you can see the process function, which pretty much just like runs the function and pass on the response from that function to the next one. So how can we make that more extensible and more useful for us? So there isn't actually a pipeline pattern in the original book, but there is one called chain of responsibility. And what chain of responsibility does, and this is, I'm showing you just an implementation of it. It's a very simple one. But the way it works is you instantiate each of the classes who executed a step. I mean, I just defined this name, execute step. And it sets the next step for each one of those. And then it executes the last one, and it should cascade from the initial step to the last one. All right, how is the pipeline better than that? So pipeline will, instead of setting the next step, you just say, those are the steps, run it. So it looks a lot better. I'm not going to explain like details of the implementation. It's very simple. You can see from the presentation later. But now, instead of setting the step in the previous step, you just add several steps and say, execute it. And there's also an improvement we can do on that, which is instead of like using classes, we can just use the dynamic behavior of Python to just set like the strings, the import strings for our functions around your code, and it will import it automatically and run. So this is pretty much the same pipeline I showed before. I'm just calling in a different way. And the interesting thing is that like Python Social Auth actually used this for their pipeline. And this is used for you to run stuff whenever the social login is finished. So you can use, it has several things it does by its own, but you can also just input and plug in your own code like this one to run whatever you want. So very extensible, very useful. All right, I had another pipeline, another pattern I wanted to show, but I don't have enough time. So I'm just going to run for some takeaways. So the first thing, design patterns, they are not created, they are merged, just like the architectural patterns that I showed before. It's not about someone getting there and saying, this is a new pattern. You You learn about them, you see people doing them, and then you say, this is a pattern. You cannot just create out of the blue. The other thing, design patterns are tool for communication between programmers through speech and code. So you don't want to learn this just to brag about how you know about design patterns and how you are so smart. You want to learn it because you want to communicate better with your coworkers. You want to be able to discuss about strategies on how to write better code, and design patterns can help you through this. Also, when you're writing code, whenever you say something is adapter or something is a pipeline, you're clearly communicating to your coworkers what you're talking about. So it makes the code a lot more understandable. Also, respect accents and native functionalities of the programming language. So as I told you, the original book was created in Java. The examples are in Java. You don't want to do the patterns in Python the way they did for Java. You want to use the features Python has and use just like the dynamic imports I showed, use those in your favor. Also, some of the patterns showed in the book, they are built in Python, so you don't actually need to rewrite them. And read source code. That's the best way to learn about design patterns. All right, so just let's answer this quick question. Are design patterns, the programming design patterns, a kind of a pattern language? And the answer is I'm not sure. So are they an elegant format to refer and debate? Yes, they are. That's one of the main things they are. Together, patterns should form a language that produces coherent objects. So given a bunch of design patterns to two programmers and a problem, will they come out with the same or similar solution? I don't think so. I think no. And the last one, improve people's life. Well, not generally, but like maybe programmers, so kind of. Cool. So to end, I just want to leave you with this quote. It says, good architecture is about improving people's lives. And most of the time, this means that what feels more natural or more pleasant to us. And I think this applies both for architecture and for software development. Thank you. Do we have time for questions? OK, so we have time for questions.
We'll just take like 2 questions, and then we're going to go on a break.
Any questions? All right. Thank you. So the link is right there. If you can find it, you can find both the presentation and a repository on GitHub with all the examples. So you can explore there. Thank you.